All right, hi Al. Sorry this come so stinking late. I was without my iPad for a while and did not have this question anywhere else. And yeah, it's crazy late. So hopefully it's better late than never for some of you. At least you got a peek at stuff you should be thinking about. So this was the one we worked out in class, looking for the formula of the unknown product. This is really just relying on this idea of conservation of mass, looking at the fact that any values that are present in the beginning of the problem, right? Any of the carbons or hydrogens or oxygens that we start with in the very beginning, they have to end up over here, right? We are going to end up having them over here in the end. So any carbon in the unknown product must come from that C2H6. All the hydrogen in the water must come from that C2H6. And we start out knowing the exact amount of that C2H6. So that's what we're relying upon, is this perfect reaction. We don't have excess of anything, and we know how much of everything we're starting with. Therefore, with some stoichiometry, we can figure out all of our totals. So figuring out our X value, which is the carbon moles, that's the easier one, right? We just start with our mass of the C2H6, use our stoichiometry within the molecule right here to get from moles of C2H6 to moles of carbon. That gets our moles. There's our X value. Pretty straightforward. The Y one was a little bit trickier. For this one, we had to recognize that, gosh, we can't get oxygen directly because all the oxygen that we started with from our O2, some of it goes to our unknown product and some of it goes to water. So instead, we rely again upon that C2H6 amount and get to our hydrogen amount. That allows us to figure out our number of oxygens that end up going to our unknown product. So we do some stoichiometry, figure out number of moles of oxygen from the water that went there. Then we can take our total amount of oxygen that we can get from our original oxygen amount here, subtract that amount of the water from the water, and that gets the amount of oxygen in our unknown. So again, relying on our understanding of conservation of mass and using it combined with stoichiometry to answer problems. All right. And the one I posted, I am not going to go through, and this is a very, very long problem, and if you haven't worked it out already by now, then you're not going to do it by tomorrow. So I just want to highlight some key points here. So hopefully you guys are going to see this and see that the video is not so long that you'll, watch it and to get a few pointers. So here we see we've got all this stuff. All of this gets dumped in a total volume of 1 liter of water. So we know from this 1 liter of water that anytime we're looking for a concentration of anything, it's going to be the number of moles of that thing divided by 1 liter, because our total volume is 1 liter, right? So that's the total volume. That's the volume we will use every time in this example. So we see this here, and it says write a reaction that produces a solid. So you need to use your solubility rules, your activity series, and determine a reaction that will produce a solid. So here you could do a single replacement. Let's see. Yeah, the copper and the silver, right? So you could do the copper with the silver, you would end up getting copper metal. There's a single replacement, it would produce a solid. Let's see, will the zinc, I don't have my chart in front of me right now, I'm just going to walk you through the steps. You could test and see if the zinc and silver would get you there. But the copper and silver sulfate totally would. So anyways, you pick a mixture and then you're looking at those. So I would look at these two and I would get my limiting reaction, right? Reactant. And to do that, I would do theoretical yield, right? So this would be copper plus the Ag2SO4, right? That's going to produce your silver solid. And then your copper sulfate. Okay. Right, so there's our reaction. We would find the limiting reactant. We would do a start from the 12.0 grams of copper, and you would start from the 89.6 grams of the silver sulfate, and you would take those and get to a product. It wants to know later the mass of solid product formed, so I would just aim for that silver, right? So you would figure out how many grams of silver, pick your limiting, then you'd have your limiting reactant. For part D here, you would have already determined your theoretical yield or your grams, so that's done. Net ionic and ionic equations, remember the full ionic equation. So if we were to do a full ionic equation, let's come all the way down here, of our equation up here, we would have our copper, right, that's solid, with our silver ion, because this would have been aqueous, right, so there's our silver ion, and we have 2 of them from that balanced equation. Is that equation balanced? It is not. There we go. So, and those would be silver ions. Then we would have our sulfate ions. There's only one from the balanced equation, right? That's everything that's on the reactant side. We have our solid copper and our 2 ions. Then on the product side, we would have our 2 silver, because those are solid. And then we would have our copper ion and our sulfate ion. Right? So that's the net ionic equation, the full deal, everything that is ions, everything that exists on both sides that can be canceled. I guess you could simplify and do a net ionic by canceling out those sulfates, and you would have copper and silver ion to create silver and copper ion. This will come in handy. You need to know this review from ALT 5. Let's see, then you have part E, determining the concentration of all the ions remaining in solution. And this is really the part that I want you to think about. So if we do F first and look at our beaker model, right? So if we have our beaker model, I would say, okay, I've got my copper on the bottom. That's my copper. I've got my silver ions. They're in solution. I've got my sulfate ion, it's in solution. Then on the flip side, I'd say, okay, I don't have silver ions anymore. Now I have silver metal, that's chilling out on the bottom. But now I've got a copper ion and I've still got my sulfate ion, right? There's our beaker model. Notice this beaker model only includes the stuff that we used in our reactions. This question's a little vague. I wanted you to end up doing it for everything. So in addition, you would be saying, gosh, but there's also some zinc and also some nitrate and also some lead. But that gets big and fussy and you know, so just draw whatever is in there. So you could simplify it if you want, just for the sake of you have no more time, and just do it for that equation. But remember, just answer the questions. So then determining the concentration of all the ions in solution, right? So if we're going to look here, sorry, let's get a different color. If we're going to look at this guy, now we need to say, okay, how much of everything did we have? And this is where the math part comes in. So we already did our theoretical yield from part D, right? So we know how much of everything we have. And so what you want to do to figure out concentration is we're going to need moles of everything, right? So we're going to need to figure out, okay, how many moles of this do we have? How many moles of these guys do we have? Total, like from our actual value, right? So we're gonna have to use our gram values, and that's gonna get us to moles of there, the gram values of this guy, that's gonna get us down to our moles of those, divide by our volume, anything that's aqueous, and we get a concentration. Solid, or the copper is a solid, right? So there's not gonna be a concentration there because it's a solid, but all the ions, get the number of moles, divide by the volume. Then look to the product side. What do we have over here? Well, now the silver ion is gone, but now we have copper ion and we have sulfate ion. So we would take however many moles we made, right? We would have figured that out in our stoichiometry, number of moles that we actually have divided by that 1 liter. Now the trick to this, everything seems pretty straightforward, but the trick is don't forget about your excess reactant, okay? So for part E here, really look at this. Don't forget the excess reactant. It's super important to realize. So let's say you mix in, 2 moles of copper, 2 moles of silver, and 2 moles of sulfate, or 1 mole of sulfate. So those are going to go together. The 2 silvers will react with 1 copper. You'll have 1 copper left over. So not all of the copper metal will become copper ion. So you just have to pay attention to that. How much do you actually have? How much is your product? How much is your reactant? Is there any excess reactant? How many ions are in there? So be really thorough when you are looking to that, and you should be good to go. I hope this is helpful. Sorry it came up late, but you had a giant clue as to questions on the test moving forward. So that's going to have to be good enough this time. All right, good luck. I'll see you tomorrow.